When you're in the shower, holding onto a wet, slippery bar of soap can be quite a challenge. It often slips out of your hands, almost as if it's playing tricks on you, much like the unpredictability of fate. But if the soap has a textured surface, it's easier to grip and less likely to fall. The ridges and grooves on the soap interlock with your hand, creating a mechanical force that helps prevent slipping. While many think rougher surfaces have more friction, smooth surfaces can also exhibit significant friction. You can use 502 glue to stick a smooth plastic water bottle, and it won't easily come off, even when filled with water. The glue doesn't chemically react with the bottle, and since the bottle's surface is smooth, there's not much interlocking. So how do they stick together? The molecules in 502 glue are polar, meaning their charge distribution is uneven, making them easily attracted to other polar molecules through van der Waals forces. The PET plastic used to make the bottle is also a polar molecule, allowing it to form van der Waals forces with the glue. If you try using 502 glue on a water bottle cap, you'll notice it comes off easily after hardening. This happens because the cap is made of HDPE, a non-polar material that can't form van der Waals forces with the polar glue, leading to a weak bond. This demonstrates the adhesion theory in tribology, which explains that friction occurs not just on surfaces but also within materials. For instance, when you stir a glass of water, it eventually stops rotating due to friction between the water molecules, not between the water and the glass. Imagine the water in the glass as being made up of countless layers of molecules. The inner layers cause the outer layers to rotate through friction, while the friction between the water and the glass is minimal. If a substance had no surface or internal molecular friction, it would be the slipperiest material. Does such a substance exist? In 1937, scientists found that cooling helium-4 to 2.17 Kelvin by reducing pressure causes the boiling helium-4 to suddenly become calm. They named this liquid helium at this temperature a superfluid, which behaves very differently from classical mechanics. For instance, if you stir a regular liquid with a motor, objects on the surface will rotate due to friction between the liquid molecules. But if you stir a superfluid, the objects on its surface stay still because there's no friction between the superfluid molecules to drive the rotation. Interestingly, when you pour out the superfluid, it appears to flow through the glass bowl as if it were a glitch in a video game. This is actually an illusion. The superfluid doesn't seep through the gaps between the glass atoms. Instead, its extremely low friction allows it to climb up the inner wall through capillary action over the rim, and then slide down the outer wall until it's completely drained. Because it doesn't create friction with other objects and has no internal molecular friction, it is considered the slipperiest substance in the world.